last talk of the year.
Hi, everyone. Does it work? I think it's weird. Last talk of the year is pretty light, so I appreciate you staying behind. I'll try to make it entertaining. A+ forms. Hi, I'm Nikolay. Like hugging Pokemons and helping people. Basically, I came here today to talk about one of the projects I built recently. It's about the forms. Forms is actually like a very interesting problem. It's supposed to be simple. You're thinking like, well, it's a thing. You just throw in a couple of inputs, and it just sends everything where it's supposed to be. But recently, my day job was in a company where we make a lot of forms, and rather complex forms. To mitigate all these problems of maintainability, well, basically, like, so developers wouldn't cry. But before we go to the actual forms thingy, there is so many libraries that help you to deal with the complexity, and I kind of don't want to, I don't know, compare it. Like, I'll leave the comparison to you, but I'd like to express, like, tell you where this library grew from, like what the thought behind it. And this thought behind it is basically how we understand complexity, how we perceive it, and how we can manage it. So I'd like to present you this little experiment. It's called the Solar System Physics Project. Let's say you want to understand how the solar system works, right? There is something like 1,000 bodies in the whole thing. And normally you need to kind of like write an equation for every interaction between everybody, right? Which yields us something like 1,000 factorial equations, which is like this much. So it's pretty safe to say it's incomprehensible by, well, at least by humans. We can simplify the problem, okay? We can pick 10 largest bodies, okay? And we're kind of thinking like, okay, we simplified it enough, we can understand it now, right? And we express all the interactions between the bodies, which will be 10 factorial, which is actually like 3.5 million interactions. So it was actually like, turned out to be a very hard problems, and people were thinking about it for a while. And eventually they said like, screw it, it's magic. God invented it, so it's like all beautiful. They built this abstraction on top of it. It's like this thing called geocentric solar system model. So like the Earth is in the middle, everything else revolves around it in this beautiful pattern. They spent like centuries recording all these dots where everything occurs, and they basically attributed it to the smartness of the God. Basically, like, the common thought was, don't worry your pretty head about it, you won't understand it. Then this guy come along and he's just like, well, you know, you're kind of doing it wrong. So he postulated a bunch of things. He created this law of gravitational attraction, right, to express how like bodies can attract to each other. He invented the idea of superposition of forces, so you could calculate forces independently and then get like a summary force from, well, summary. And then he said, like, you know what, the sun is actually infinitely has more mass than everything else, so you don't need to bother to calculate interaction between smaller planets. Just calculate it between sun and every planet. Okay, and he narrowed down to 18 equations. Well, actually, he didn't know about Pluto, so 16. Manageable, right? He actually calculated the whole thing. So this story comes from Gerald Weinberg. He is what's called system thinker. He thinks about complexity and stuff for living and how we humans deal with it. I highly recommend reading his books. That will change your mind, or change your life. Mine too. Anyways, back to computers, back to our steamy underground. That's where IT department lives. We kind of have actually similar problems. We've got this thing called explicit code. When you've got a whole bunch of moving things thrown at you, we're too afraid to call it shitty code. We just call it explicit code. But the problem is the same. Oftentimes, it's incomprehensible. It's just too much complexity. You cannot understand it. The other option is magic. You take it, you wrap it underneath some abstraction, and you say, don't worry your pretty head about it. It does what it's supposed to, right? But if you think about both cases are useless. In one case, you cannot comprehend how a system works because there is too much in it, too much complexity, too much details. In other case, it's useless to you because it hides all the implementation details underneath some abstraction, and you don't know what's going on under the hood until it explodes. And then you go and deal with the 1,000 equations, right? But there is a middle ground which you could call reasonable code. It would look something like that, where you actually, well, that's kind of equivalent of what Newton would do. You express interactions. If you're reading this piece of code, you kind of although even you don't know what it does, underneath, right? You can reason about it. You can say that it calculates all these interactions, and you know kind of instinctively if you say remove one of the lines, it will calculate less, right? It will kind of give you less detailed model, right? So reasonable code. Back to our forms, explicit code, bootstrap. If you start adding this stuff all over your place, it will become your technical debt immediately. Your engineers will be crying. That's just 3 input fields, right? Well, 2 of them in the checkbox. Imagine you have, I don't know, 12 inputs in it, and you're collecting some data, I don't know, whatever you need, and you have a dozen of those forms in a project. So it becomes incomprehensible very quickly. I mean, you can kind of understand what's going on, but your brain cycles will go into waste, basically. Moreover, on top of that, we add in another layer of abstraction, Redux, because everything has to be attached to Redux these days, right? And then we also have this homemade kind of halfway abstraction for fields, and you have 3 things smashed together, right? You kind of understand what's going on, but there are so many details. It's, again, hard to reason about what this thing does. Remember, back in the day, how forms used to be? You would have a form, you throw in a bunch of input fields and a button, and it sends everything where it's supposed to be. Everything was pretty awesome. Touch of genius. This thing survived for ages for a reason. Well, now, forms. If you think about forms, if you saw a lot of them, they all have the important things, right? What type of data we're collecting, right? That's the interesting part about form. How do we validate it? Where does the data go? Right? Those basic things you would like to know about a form when you look at one, right? So with this mindset at hand, we created thing I called A+ form. So we sort of got fed up with all these libraries that promise simplicity, and in a month or so we want to get rid of them. So we decided to build one that will stick around, and it actually was sticking around for a year for our company, and it was growing beautifully from like medium to very large forms easily. So it looks kind of like that. You import form and a text input and a password input. You get them together just as they used to be, and you have a button. And on submit, it just calls your thing. Does this code looks reasonable? The beauty of it is to minimize, the idea is to minimize the like interface footprint, the knowledge footprint. All those inputs pretty much behave exactly as your normal inputs that you use, like, I don't know, when HTML was static, right? They pretty much have exactly the same function. They just have smarts underneath them. For example, the rendering itself of the input kind of decoupled. You can declare layout, which again is super simple stateless function. You've got your label, you've got your input, and you've got error. You don't care at this point which input it is, although you might check the type of input. You don't care about validation. You don't care about anything. You just render stuff. Pure and simple. Another thing is reusable components. When you start building really complex forms, you will really want to reuse things. For example, say you've got a select, right? React select is pretty great, right? And then say you want a country select. And you want a country select as a component. Usually it ends up with pretty massive things, right? We had this problem so much that we built basically a helper. You can take any input, rewrap it, and reuse. For example, in this case, I'm building a phone input, phone number input, right? I took the text input, the existing text input, and I replaced on change with a thing that formats text. That looks reasonable. You don't need to worry about validation here. You don't need to worry about how it looks like, where it's going to be used. It's a one-direction data flow. You just get a value as a probe, and when you're done, you send data into onChange. That's everything. And you can combine other inputs into compound inputs. You can create array inputs. In some cases, we have inputs nested like 7 times. For example, we have an input which like a regular input, then there is a select on top of it, and there is a country select on top of it, and then country select and a state select, and like smart Google location connected thing smashed together into location picker. And that's, again, when you see location picker in your form, you know, well, that's a location picker. Here's your name, label, done. Moving on. It's actually 100% testable. When you start building really complex, especially dynamic forms, testing becomes paramount. You don't want your tester to bounce things back and forth because it's a really crappy problem to deal with. So we build it with testing in mind first. And testing is really simple because, again, all those inputs behave as normal, regular HTML inputs. You just grab an input, you assign a value, you submit a form. Crystal clear. And it tries to mimic a normal input, although underneath it, it can be anything. Make sense? Server-side validation, also a huge pain in the neck. Say you have some function, say it's a sign-up function, right? Which takes a username and tries to check if it exists, right? So it's like a last line of defense. And if the username exists, it throws like 422 error. You can reintegrate that back into the forms just like that. So we're making a request with Axios, sending data to the server. If it explodes, we're checking if the status is 422. We know that this is a validation error. You just raise an error. That's it. Form will know that submit exploded. It will pick up this instance of the exception, extract all the errors, pass them down to specific field. To the end user, to the developer, there is no difference between front-end and server-side validation anymore. Exactly the same experience. They wouldn't even notice. Well, you obviously can Redux like an alpha. That's pretty much it. So there are a lot of forms. There are a lot of form plugins. Not all of them actually equal. A lot of plugins they start with a good idea, but they start with a custom-made interface. Half a year down, they decide that, well, initial idea wasn't so great. Right now, let's rework everything. And if your library, if your application is heavily invested in that application, you're doomed. Upgrade going to be costly. We're trying to avoid this by relying on standard HTML semantics. We're not inventing homemade syntax for it and homemade APIs. We're taking what's been working for decades. We're just making it smarter and reusable in modern environment, which allows us for rapid form developers. When you throw in an engineer to build a form with this library, they don't need to learn this library. They just take those components, throw them together, form is done. It might look like a bit off here and there, but they can mitigate that problem later in like styles department. The actual form stays like simple and reasonable. Code that being built with those forms does not change that much. We used to have Redux forms and Bootstrap forms, bunch of other libraries, and those forms iterate a lot. Every time designer decides like, well, let's move this thing over, the whole code is being changed all the time. With those forms, no. You just threw like components together. If the worst case scenario tomorrow, product owner comes and says like, well, this field should be like a bit lower. Yep, swap, done. Make sense? Testability is a huge pain in the neck with a lot of libraries. Yeah, for us, being able to write detailed unit tests and ship reliable code, especially for smaller teams with less resources, is paramount. And being able to customize and reuse what you've got is also a huge win. That's pretty much it. Thank you. You probably it's probably late for questions, but there is documentation, and I'm trying to kind of get it in the hands of other people. So just ping me on Twitter, and I'll be more than happy to answer your questions.
Cool. Thank you, Nikolay.